So before you actually design any ETL process, to design a efficient ETL process and design a efficient error handling scenario, you have to know what all possibilities are, what all possibilities of anomalies you can have in your source database. So if you know that, then you can probably design close to perfect ETL process which can handle all the scenarios. So that process of that is the quality of the data. To identify, the quality is a subjective, it's actually depends on the perspective of the system, right? Like say a data which is good quality for one system might not be good quality for another system. Like say, for example, like say there is one system which needs the address of a person, but it is okay to just have the postal code. You don't need street address or unit number or anything. So for that system, a data which contains only postal code is good quality. But another system which needs the complete address, which needs everything from the name of the person to up till the postal code, that system might not have that, rate that data as 100% good quality. So data quality is actually a subjective term. It depends totally on the end user, how good the data is which is flowing into your ETL. So as it is a subjective matter, you need to understand your data before you design anything. So the quality of data actually plays a big role in taking decisions of your design. So let's see what they say in the slide. The data quality, there is an inherent trust on the data by the end user. So okay, so they are actually saying that the data we are supplying to the data warehouse is actually assumed by the end user that it is perfect quality, right? We are doing so many things starting from extraction, transformation and loading. Your data is passing through so many different databases, so many different transformation processes to get to the form you are providing to the user. So even in this ETL process, you can actually smudge the data, smudge the quality of the data. You can wrongly transform one to another because these processes are designed by humans, so there could be human errors and there could be scenarios, data scenarios which a developer missed. So the quality, to maintain the data quality in a particular ETL process or in a data warehouse system is very, very important. So that's what this slide says. So end user whom you are providing the data assumes that the data you are giving is accurate. So failure to give the accurate data may lead to serious misinterpretation of the report. So and lead to wrong decisions. So the data you are providing seen by the user, he could interpret it wrongly. Your purpose is not solved here. The purpose of the end user is not solved here. If you give him wrong picture, he will take wrong decisions. So to avoid that, we need to maintain the quality of the data. Okay, so now we will discuss different perspective of data quality, right? So as I said, you can basically see the data in few perspective, right? The quality of data in few perspective. You can measure the quality. Like one of the measuring meter could be your data accuracy, like how accurate the data is either from your source or what you loaded in the target. So for that, let's see this example. If a customer, what exactly data accuracy means? So if a customer, in this example, if a customer with ID 111 by name Amit stays at address 1 from 2001, then for occurrence of ID 111 with name Amit and date 2001, the address should always be address 1. So based on our extraction, we could either get address 1 or 2, or if we missed out address 1 because one of our load failed, and then it just show address 2 or something like that. So 2002, he is actually staying in address 2, but your job failed and or something happened with your data, and then you still see the address 1. So the data which you see in the data warehouse is correct for that particular time, but now it's not correct anymore. So that is called data inaccuracy, right? It's not really wrong, but it's inaccurate. And also it could be the case where another example could be like you had a name of a person, say Amit, like my name, Harish Krishnamurthy. It's a big name, it's a long name. So in your some ETL process, you might have defined the column length to be smaller than what actually is stored in your source system. So it could get truncated on the way. So you have to design your ETL process in a way that you maintain the accuracy of the data throughout. So that perspective, so you can measure the data quality on data accuracy. Second perspective is timeliness. Okay, so actually we discussed this scenario fits here also, that like if the data timeliness is you give correct data at the time when your reports are being seen by a user. So generally in a data warehouse, it's not timeliness is a perspective, right? So in a data warehouse, your data warehouse is always say on a time period basis, like monthly or daily or hourly or whatever case, but for that time your data should be accurate. So in this example, if a package got delivered on 1st of Jan 2000, in this case maybe probably they are looking at a ODS, operational data source, maybe not a data warehouse, because it's like doing some transactional reporting. So if a package got delivered on 1st of Jan 2000, it is not updated immediately, but updated in the warehouse on 2nd of Jan 2000. So if an end user actually fires the query on the database on 1st of Jan, a product is actually delivered, but your data warehouse doesn't give you correct count because it's still not updated in your data warehouse. So data timeliness is very important. So data timeliness can be achieved by designing your reporting system based on your user requirement. So if a user is firing queries on 1st of Jan and need the 1st of Jan transaction in your system, then you have to make your system maybe hourly or maybe once in 2 hours. You have to update your data warehouse. Otherwise, it's not accurate by the user's perspective. So this data timeliness is also one of the data quality perspective. Another one is data completeness. So data quality can be measured by data completeness. What exactly you mean by complete data? As I said, quality of data is depending on the usage of the data, right? So as I gave you the example before about the address, if one system having only the postal code, you could say that my data is complete and this is what I need. But another system could require everything about the address so that the data is considered complete for that usage of the data. So that is data completeness. You receive complete information. So there's a saying that half knowledge is not the, I don't know exactly what you say, but it's like half knowledge is not always the correct knowledge. So it's like if you have half information, for some system maybe it is complete complete for that particular system, but it might not be complete for the other system. So that is data completeness. This is one of the measuring parameter of data quality by seeing the completeness of the data as required by the user. So in this example, there is marketing department and R&D department, and there is product information being shared between these two. What is complete for a marketing department might not be complete for R&D department. So there is a possibility that data is complete but not accurate. So this is data accuracy. Okay, I think this slide is a bit confusing. What's the last point? If all three columns are provided, then the data is said to be complete, but the phone number, yeah. So they are saying that name, address, and phone number for marketing department, maybe they just need the phone number. Maybe they just need the name of the guy to send name and address. Maybe just need a phone number of the person to send text. But for R&D department, maybe they need all the demographic of the person to do their research on the data. So that is one of the measuring parameter of data quality, that is completeness. How complete is your data? Okay, so another data quality measuring parameter is data consistency. So data being consistent across all data set, what does it mean? Let's take this example. A credit card that is inactive cannot show billing status as due. So that is, if you have, say, let's take another simple example. Let's say you are loading two different data marts from your data warehouse, right? So you are maintaining the same part of information in two different data marts. Say the address of a person, you are actually maintaining in system A, data mart A and data mart B. But while loading your data warehouse, your job to while loading your data marts, your job to data mart A ran fine, but for some reason the job to data mart B failed. So the address of this person in data mart A is current address, but the B one is still the old one. So this is actually not consistent across the system. So similar example, insurance, a similar example which is given in this slide is insurance policy that has expired cannot show next premium due date as 1st Jan. So that means that these are business rules, right? So the consistency can be taken in different sense. One is the sense which I told you, where the data is not consistent across different systems. But in this case, the business scenario is the data is not consistent by the usage of the data. Like insurance policy has already expired, how can you give me another due date for it? So data has to be consistent. But I would say this example is basically giving accuracy of the data. I don't know how it's the consistency. So yeah, they're just saying that there are multiple data marts using the data, multiple business users accessing the data in two different data marts. Hence, if two different business users get conflicting information for their reports, in one they see that the insurance is still it has still a due date, and the another system shows it's expired or whatever. So it's not consistent across different systems. Also, if a product code, another example they are showing is a product code for certain product is product 123, and another system it is showing product 124. It is not consistent across different systems. So this is data consistency, which is another measuring parameter of your data quality. Next one is data duplication. This is basically just redundant data. This is not very, I wouldn't say it is, it's not a very serious data quality issue, but it's still very, it's still applicable, because data duplication in your data warehouse can cause a lot of memory space issues. So if you keep duplicating the data, or also it could give you wrong reports when you have duplicate data and you try to join it with your dimension. Maybe it gives random counts or random aggregates. So logic has to be built in your ETL jobs to handle all these data quality issues. Guys, just give me a moment. I think my battery is dying. So the next parameter or the next measuring parameter for data quality is referential integrity. So like we discussed about referential integrity in our previous classes, like when you have a fact table and a dimension table and you're loading the dimension keys in your fact table, then you want to make sure that the dimension keys actually you are entering in your fact table actually exist in your dimension table. So this kind of referential integrity has to be maintained either in your ETL process or at your database. Basically, it should be done at your ETL process, because if you maintain at your database level, then your job will fail if it runs and it fails the data integrity. So what I mean by maintaining it at the database level is you can create physical constraints of foreign key and primary key on your database level. So if you do that and your ETL job runs and it actually fails that referential integrity to be maintained in the data, then the ETL job will fail. So before even it reaches your database, you should handle your referential integrity within your ETL process. So you shouldn't load those data which doesn't really follow the referential integrity. So how can this referential integrity fail? Let's consider this example. Like we have a dimension ETL process, right, to load dimension tables. We can have a fact loading ETL process. So you will have two separate processes. So you are extracting from two different tables in your source, and you are doing it based on your incremental load, say date. You are performing incremental loads. So say when you actually read from your fact table, sorry, let me come back. So you are having two different ETL processes. One is loading your dimension table, another one is loading a fact table. So you are doing incremental loads for both. So say you are loading your dimension table, but based on your date, you actually missed one dimension, which is supposed to go into your dimension table, but because of the date constraint, you actually missed that records. It is ready to be loaded in the next one, but in this load, you actually missed that dimension value. But when you are loading fact transactions, your transaction actually, the fact transaction table actually captured the data for the new dimension also based on the dates in the fact extract in your, so based on your extraction date, you actually had the transaction which is supposed to come in the next transaction. Somehow your date messed up or your transaction just slipped out. Something happened. So the dimension load actually missed that dimension, but your fact load has the data for that dimension which was missed. So in this case, the referential integrity is not maintained. So these kind of scenarios has to be maintained in your ETL process. So when you load your fact table, before loading it, you have to check your dimension is all existing in your dimension table or not. This way you can handle the referential integrity of your data. So that is one of the data quality parameters. Another one, we actually discussed about this parameter before in the data anomalies, which is domain integrity. Like data, so the example they are giving here is gender field must contain two values M and F. So this is domain of the data. So any set of values has a union set, right? So the union set contains all the distinct values which are possible for a particular column. So this domain value for gender is M and F. If anything else like S, U or whatever unknown comes through from a certain system, it should fail. So this is another data quality measure where you have to check whether your data is within the decided domain or agreed upon domain. This is another parameter which decides your data quality. If the domain constraint, or you can do check constraints like we discussed in our previous anomaly class, where you can put domain constraint on your age where it has to be numeric, or you can put domain constraint on your date of birth where it should follow a certain date format, whether it has all year, all the required parameters for a date like year, date, DD, MM and YYYY or whatever expected format. So it should actually follow a certain domain constraints. So here they are showing the domain. Actually domain is basically set of a closed set of values which it should follow. The second one which I said about the date format is data accuracy. Sorry, I mentioned it wrongly here. But the domain means set of values which your data has to follow. So example here is set of your date should follow should fall between 20 to 30. If it exceeds or if it's less than that, then it should be rejected. So this is domain integrity. Integrity of your data which has to follow certain domain like coding standards or currency, like we discussed an example of currency where list of currencies are valid, the other currency is not. Anything else other than that domain value should fail. This is one of your data quality parameter. So the next data quality parameter is it should follow certain business rules. So in your data warehouse you can actually design it based on your user requirement, right? Like we discussed before, you can have certain filters or based on the business, what business needs, and or you have to transform your data in certain format, or you have your currency only in US dollars. If rupees comes in, you have to reject them or something like that. So these are business rules you define. Basically, you define basically based on your users' requirement. So these business rules also decides data quality. So as I told you before, the data quality is a very subjective matter. It depends on the quality of the data totally depends on what is the requirement. It could be good for one system, very good for another, excellent for another, or very poor for another. Same set of data could be of different quality. So this is one of the rules which actually tells you that why it is so different, because business rules on different data for different system could be different. So if it follows that business rule, then your data is good for this particular system, but the same rules doesn't apply to the another system. So the quality is different for different systems. The example they are giving here is, if there is a business rule saying the department must contain only one manager, this example we discussed before, or one employee can work only in one project at a time, then the data in that warehouse must reflect the rule. So in your ETL process, you have to formulate your ETL jobs in such a way that you actually handle these business rules. And if it doesn't follow the business rules, then your data quality is not following the business rule, and it's not good as far as your system is concerned and your business rules are concerned. So that also is a measuring parameter for your data quality. So with this actually tells you all about what different kind of data quality parameters are there, how you can decide your how you can decide whether your data is good quality or bad quality. So these are different parameters on which you can measure your data quality.